Hello class, today what we're going to be looking at is what in a diagram can we assume to be true and what has to be labeled. Because some things, we can say, hey, it looks good, and so we'll go with it. But most of the time we need things to actually be labeled, have some kind of marking to let us know that's what it is. So look at this diagram right here. Answer the 5 questions here on the screen. True if you know that this is good. False if it might be good, but we need more information. So I'm going to pause the video right now and we'll answer that. Okay, so let's take a look at what we have. Question A, all the points are coplanar. True or false? Well, this is actually going to be true. Unless there is a plane actually drawn on the diagram, we assume everything to be in the same plane. It's all there, and so we don't have to have another plane drawn on there to specify. All right. Points D, G, and I are collinear. Well, looking at this, we've got D, we've got G, we've got I. It looks like they might all be in a line. Can we assume that to be true? And that is false. Just because it looks like it's in a line, unless there's a line actually drawn between them, then we have to assume that these are not collinear unless we can prove it some other way. C, A, C, and H are collinear. Can we assume that to be true? And yes, we can, because you see we have line AH right here showing that this is in fact a true statement. We can't assume that to be a straight line. Okay, question D, we have line EG and line AH are perpendicular. Is that true or false? And we say, yeah, that's true. How do we know? Because right here we have this little right angle box to show that this is a right angle, which means the lines are perpendicular. So that's good. Next, angle BCA and angle ACD are linear pairs. So we have angle BCA, angle ACD. Can we assume that this is a linear pair? And the answer is yes. Yes, we can assume these are a linear pair because line BD right here, we can assume that to be a straight line. And these are adjacent angles, so that works. All right. So we've got a couple more. Here we go. Same diagram. We've got a few more. So again, pause the video and answer these questions. Okay, so we're back. And let's see here. F. Line AF and line BD are perpendicular. So we've got AF right here. We've got BD right there. Well, they look perpendicular. Can we assume that they're perpendicular? And no. No, we can't assume that. Because unlike over here with AF and EG, we have the perpendicular box, the right angle there. Up here with these, we don't have anything saying that this is a right angle. For all we know, it could be an 80-degree angle, which looks pretty close, but not exactly. G, we have line EG and line BD. So there's line EG and there's line BD, and we're going to say that those are parallel. Can we assume that to be true or false? False. There is no marking saying that these are parallel, and so we don't know. If this is off by even 1/10 of a degree here, then these lines will intersect way down here somewhere off the screen, right? And so not parallel. We can't tell just by looking. We have to have some kind of marking saying that they're parallel, or some other information so that we can conclude that to be true, which we don't have. Line AF and line BD are coplanar. So there's line AF, there's line BD. Can we assume these to be coplanar? Yeah. In fact, earlier we said we can assume all of this to be coplanar. So sure, we can assume those to be coplanar. Because again, we don't have any other plane there to suggest that some of this is on a plane other than the paper that it's drawn on. Alright. So line EG and line BD right here. Can we assume that those do not intersect? Well, hopefully, since if you got G right, you should get this one right. No, because if they don't intersect, that would mean that they're parallel. And we already said we can't conclude that this line is parallel to that line. So again, that would be false. Okay, so we have line AF and line BD. So AF and BD. Can we assume that those intersect? Yes, we can, because they intersect right here at C. The only ways those would not intersect is if they were not coplanar and they were skew lines up above each other. But as we already said, we're going to assume that these are coplanar, unless we have information to show that they aren't. They simply are. So yeah, they intersect right there at C. Okay, next we have line EG and line BD. Let's see here, sorry. Yeah, line EG and line BD. Can we assume that those are perpendicular? And no, I've got a typo here. Oops. That is false. False. EG and BD don't even look perpendicular. But for them to be perpendicular, they would have to intersect somewhere at a right angle. And there's nothing to show that they intersect at a right angle. It would be kind of hard, since this is a right angle, for these to also be a right angle, especially that. But yeah, we are not going to be able to assume that. There's no information saying that. Okay, so we have angle ACD and angle BCF are vertical angles. We're talking about this angle and this angle right here. Can we assume that to be true? Yes, we can, because we can assume that these are straight lines, and so these angles are formed by opposite rays, which means they form lines. Alright, so it's formed by the intersection of two lines, so we can assume that's true, yes. Okay, and last we have line AC and line FH are the same line. True or false? True. We can assume that this is all one straight line on line AH, and since these are all collinear, then that means that these are the same line. And so we can assume that that is a safe thing to assume, so that's good. Alright, let's take a look what else we got. Okay, we've got some postulates here. Postulate, the two-point postulate and the line-point postulate. Remember, postulates are things that we can't prove are true, they are just assumed to be true. Alright. Two-point postulate. Through any 2 points, there is exactly one line. And the line-point postulate says that a line has to contain at least 2 points, which I think is kind of silly, because a line contains an infinite number of points, because it goes on forever. So, but we do have a point there. And through any 2 points, there's only one line. That's the only line that you can draw through point A and point B. All right. Line intersection postulate. If 2 lines intersect, then their intersection is exactly 1 point, right there. The line M and line N will not intersect anywhere except for point C. All right, that's it. Only one intersection. Okay, we have the 3-point postulate. Through any 3 non-collinear points, there exists exactly one plane. So we have points D, E, and F, and there is only one plane that contains those 3 points. That's the only one. There's nowhere else I can have a plane that contains those 3 points. And then the plane point postulate says that if you have a plane, it's got to have at least 3 points in it. Which again, it's got an infinite number of points because they go on forever. There it is. Next, the plane line postulate. If 2 points are on a plane, then the line that contains those points is also going to be on the plane. Right? Because if those points are on a plane, whatever line goes through those points also has to be there. And then we have the plane intersection postulate, which says if 2 planes intersect, then their intersection is a line. And that's the only way to do it. Even if you have like 2 pieces of paper, so let me grab 2 sheets of paper here real quick. Hold these up. So I've got this plane and I've got this plane, and they intersect like this at that corner of the paper. But you've got to remember, planes go on forever, which means that in actual geometric plane, those sides of the paper are going to come down, and so it would intersect at a line. Okay, so that's the only way they can intersect. So let's take a look at these. We have these pictures here. I want you to state the postulate that is illustrated by the diagram. So I'm going to pause, like you to pause the video And you can look back if you need to see what those postulates were and see which of these is which. Alright, so if two lines intersect, then we've got a point. Well, that is the line intersection postulate. If two lines intersect, then their intersection is exactly 1 point. Okay, so what about this one? We've got if, and we see two planes intersecting, then we've got a line. And yeah, if two planes intersect, their intersection is a line. That is the plane intersection postulate. All right, that's it. Let's see what else we got. Okay, I forgot to cover this one up. Pretend you don't see that. All right. Use the diagram to write examples of the plane point postulate and the plane line postulate. Well, looking at this, the plane point postulate says that if you have a plane, it's got 3 points. So plane P contains at least 3 non-collinear points, in this case A, B, and C. A, B, and C. The plane line postulate, point A and point B lie on a plane. So line N is also on the plane because line N is goes through points A and point B. So it also has to be in plane B. Alright. Okay, so last one, I want you to look at this, pause the video. Which of these statements can we assume to be, cannot be assumed as true? Alright, so let's take a look at this. Which of these can we assume to be true? Point A, B, and F are collinear. So there's A, there's B, there's F. What do we think? Collinear? Sure, we see this line going straight through it. So that is good. We like that one. Alright. E, B, and D are collinear. We've got E, B, and D. Well, it looks like they're in a line, but are they? I don't know. There's no line drawn. It's hard to tell. So this one we cannot assume to be true. Alright, line AB is this little upside down T. Hopefully you remember what that means. That means perpendicular. So line AB is perpendicular to plane S. Let's see, there's line AB, there's plane S, this one horizontal kind of looking one. And yeah, we see it's got a little right angle marking there, so that one's good. We can assume that to be true. Line CD is perpendicular to plane T. So line CD is this one here. Is that one going to be perpendicular to plane T? And actually, yes, it is, because this line is on a plane that's perpendicular to the plane. So this line is perpendicular to plane T. Because we know that right here. Because what that does is that tells us that plane T is perpendicular to plane S. So everything on plane S that intersects plane T will be perpendicular to plane T. So that one's good. Alright, line AF intersects line BC at point B. So we've got line AF, we've got line BC. Do they intersect right here at point B? Yes, they do. We can see that nice and clearly, so this one is good as well. So the only one on here that we could not be assumed to be true is this one right here. Everything else is good. And so that is it. Remember, for something to be assumed true, basically all you can really assume is that it is a straight line and that it's on the plane that it chose to be on. Everything else you have to have some kind of marking, something to show it. You have to have some marking showing that it's a right angle. You have to have some marking towards parallel, some kind of marking to show that it's perpendicular or anything like that. Congruent, all of that, you have to have some marking to show it. Alright, and that is it. I will see you next time.